Tell you about immunoregulation and pathological autoimmunity, and lessons that I think we have learned which are useful in islet and pancreas transplantation, but maybe some lessons that we're now learning in islet and pancreas transplantation that will be useful in trying to prevent the primary onset of type 1 diabetes. So I've been working looking at T-cell responses in type 1 diabetes for 18 years now. And when I first, I know, I feel quite old now. When I first started, you couldn't have had that title, which is that type 1 diabetes is a T-cell mediated autoimmune disease. I was diagnosed with type 1 diabetes in 1979, and both my GP and the specialist that I saw couldn't tell me why I had type 1 diabetes and muttered something about a virus. But now our understanding is very much better. And actually, a lot of our understanding has come from things like transplantation. So as far back as 1994, we knew that perhaps the answer to the original pathogenesis of type 1 diabetes did not lie within the pancreas itself. In a very elegant set of experiments where there was a partial pancreas transplant between monozygotic twins, so there's going to be no problem with alloimmunity. And they showed that whereas these people were transiently reversed from their hyperglycemic state, within 6 to 12 months there was a complete reenactment of type 1 diabetes. And when they biopsied the transplanted organs, there was insulitis and all of the sort of hallmarks of the original disease. And over the last 18 years or so, there's really become an overwhelming amount of evidence that points not at the pancreas, but very much at the immune system as being the primary reason why people develop type 1 diabetes. We know that bone marrow transplantation itself from a diabetic to a non-diabetic donor is actually able to transfer type 1 diabetes. It does so much less if you remove certain populations of T cells. We know that modulators of the immune system can affect the development of type 1 diabetes. So when someone's diagnosed with diabetes, they've still got about 30% of their islets left. And if you can stop the immune system at that point, and in the 80s there were very large trials with drugs like cyclosporin, we know that actually you could preserve that beta cell mass. And many of the people on that trial went off insulin for a year or more. Unfortunately, their kidneys didn't fare so well, and so we're now trying to find much more precise ways to target the pathological autoimmunity. GWAS studies have shown us that pretty much all of the genes that affect your susceptibility to type 1 diabetes do not primarily function in the pancreas or in insulin signaling secretion pathways. They are immune genes, if you like. They're genes which specifically affect T cells, T cell signaling, and actually specifically regulatory T cell behavior as well. And finally, from a lot of pathology, we know that islet-specific T cells are detectable in the pancreas of individuals at the time of diagnosis. And this is an example of a staining of so this is a section taken of a 13-year-old boy who sadly died of diabetic ketoacidosis. And if you stain for CD3, so picking up all T cells, what you can see is this profound lymphocytic infiltration. So there are T cells, there are dendritic cells, there are B cells present. And as I say, I've spent about the last 18 years trying to figure out if we can access these cells and if we can study them. Fortunately for us, people die very rarely close to diabetes, diagnosis of diabetes now, which leaves us studying the peripheral blood. However, this is an enormous challenge in type 1 diabetes. So when we're trying to study these cells, we probably spent the first 8 years or so developing tools and technologies to be able to look very precisely at islet-specific T cells in individuals with or at risk of developing type 1 diabetes. And this is a big challenge because you cannot biopsy the pancreas in people with type 1 diabetes, and there are incredibly low frequencies of circulating autoreactive T cells, probably 1 to 2 orders of magnitude lower than alloreactive T cells that you guys may be more interested in studying a lot of the time. Secondly, we don't want to just study the presence of these cells. As I hope it's become very obvious over the last couple of days, The quality of the immune response is incredibly important as well. All T cells are not created equally, and as I'll go on to show you, autoimmunity is not rare at all. Pretty much all of you have lots of islet-specific T cells going around your circulation, but it's the quality of response that determines the outcome.